All right, carrying on with Hubble, we are now looking at the fact that with the Mount Wilson telescope and its very good angular resolution and sensitivity, at least for the 1920s and 30s, that you could get these images shown on the bottom with the telescope where we see this structure of a disk and the details that you get of the morphology or the shape of galaxies. And so Hubble published in 1936 the book The Realm of the Nebula, and we see this often called it's a tuning fork, where these different types of galaxies are shown. And these labels are still often used, but the main point is separating out spiral galaxies from elliptical galaxies. And we'll get to elliptical galaxies later on. Now, our own Milky Way galaxy that the Sun and Earth live in is shown through measurements of stars and gas. We can map out, which is a little bit tricky to do because we are located inside of the galaxy, but you can recreate what the galaxy should look like if you could fly very, very far away and look down on it for a face-on view, which is shown in the center image. And this is a recreation of what the Milky Way should look like based on observations of stars and gas. And we see that it's this large spiral. And if you then look side-on, you see that this spiral disk structure is thin. And you can also then see that above it, there are some other stellar clusters, and that the central region is a bulge, which is a bit thicker and higher density of gas and stars than out in the disk. So that's a quick overview of the Milky Way. You'll notice that in the, well, you might not quite see it because it's quite small. I can zoom in. So if you look at this image, you see that the Sun is identified as being relatively far out in the spiral arms. And in fact, that distance is 8 kiloparsecs. And we see, including our own solar system, but we see other stars as well, that are all rotating in roughly circular orbits all the way around through the galaxy, with the center of that orbit being the center of the galaxy. So we can go back to our orbital motion that we had in chapter 1, and we can look at what the period of that orbit is, or how long it'll take to go one full revolution around the galaxy. So t is the time, the period, and that's equal to 2 pi r over v. So 2 pi r is the full distance, the circumference of that orbit, divided by this speed, the orbital speed at which it's going through its circular motion. And we can determine, again, from the motion of other relative stars, that the speed that our solar system and also other stars are doing is about 240 kilometers per second. And if you then do your unit conversion, then you end up with about 220 million years for the time it takes to orbit all the way around the galaxy. Since we think that the Sun is about 4.5 billion years old, then that's quite a lot of revolutions already done around the galaxy.